Trees, Scalability in Cloud-Native Applications, Introduction. Trees in cloud-native applications are hierarchical data structures used to organize, search, route, scale, and manage distributed systems efficiently. Tree-based structures are widely used in distributed databases, Kubernetes scheduling, cloud file systems, DNS systems, API gateways, indexing engines, caching systems, AI search systems, load balancing, distributed routing. A common interview topic is, how are tree structures used for scalability in cloud-native applications? This guide explains. Click Tree Data Structures. Click Scalability Concepts. Click Distributed Trees. Click Tree Structures. Click Merkle Trees. Click Kubernetes Resource Trees. Click Database Indexing. Cloud-Native System Design. Click Real-World Architecture. Click Optimization. This is one of the most important advanced backend and distributed systems. Simple definition. A tree is a hierarchical data structure made of nodes connected in parent-child relationships.
Why trees matter in cloud systems.
Cloud-native systems process massive datasets, distributed requests, hierarchical resources, fast lookups, scalable indexing. Trees help systems achieve efficient search, scalable indexing, optimized routing, fast lookup performance, distributed consistency. Without tree structures, searches become slow. Indexing scales poorly. Basic tree structure. Example, ... Root. R, service A, service B. Pod 1, pod 2. Core tree terminology. Term meaning. Root. Top node. Parent node above another. Child node below another. Leaf node without children. Height. Tree depth. Subtree. Child section of tree. Common tree types in cloud systems. Tree type. Common usage. Binary tree. Search structures. B-tree, database. Indexing, trie, routing, search, Merkle tree, distributed consistency. Segment tree, analytics. Decision tree, ML systems, binary trees. Basic hierarchical structure. Example, 50 multiplied 25, 75. Benefits. Structured search, ordered traversal, binary search trees. BST. BST rule. Left, root, right. Search complexity. Average O log n, worst ON, balanced trees. Balanced trees improve scalability. Examples. AVL trees, red-black trees. Benefits. Check. Predictable performance. Efficient search. B trees in cloud databases.
Very important interview topic.
Used heavily in. Check. PostgreSQL. Check. MySQL. Check. Oracle. Check. SQL Server. Why B trees matter? B trees are optimized for check. Disk storage. Large-scale indexing. Minimal disk reads. Architecture. Database query. B tree index. Fast row lookup example. Database indexing. SQL example. Create index. IDX user email on users email internally. CB tree structure created. Benefits. Plus, faster queries, scalable search. B tree scalability. B trees scale efficiently because multiple children per node, shallow depth, optimized I/O operations. Without indexes, next full table scans occur. Trie trees in cloud systems. Trie equals prefix tree. Common uses. CLO complicate. C API routing. C DNS systems. Search engines. Example. API, users, orders, payments. Benefits. Plus. Fast prefix matching. Efficient routing. Example. API gateway routing. Cloud API gateways use trie-like structures. Flow.
Incoming request.
Try route matching. Target microservice Merkle trees. Very important distributed systems concept. Used in Clock blockchain, Cassandra, DynamoDB, distributed synchronization, Merkle tree structure root hash, A hash B. Benefits. Check. Fast consistency validation. Check. Efficient synchronization. Example. Distributed database sync. Flow. Node A. Merkle tree comparison. Node B. Only changed branches synchronize. Benefits. COC. Bandwidth optimization. COC. Distributed consistency. Kubernetes resource trees. Kubernetes internally manages hierarchical resources. Example, cluster, namespace, deployment, pods. Benefits. Scalable orchestration, resource organization. Tree structures in Kubernetes scheduling. Scheduler evaluates X nodes, pods, affinities, topology constraints. Tree-like hierarchy improves X scheduling efficiency, X scalability. Trees in cloud file systems. Distributed file systems use trees. Examples. Check. HDFS. Check. S3 metadata structures. Check. Google file system. Example. Root, logs. Images, backups. Trees in DNS systems. DNS is hierarchical. Example. .com, .example.com, .api, .example.com. Benefits. Check. Distributed scalability. Check. Efficient domain resolution. Trees in load balancing. Cloud load balancers may use tree-based routing. Example. Global load balancer. Regional load balancer. Application servers. Benefits. Distributed traffic handling. Scalability. Trees in AI search systems. Vector databases and search engines use trees. Examples. HNSW graphs, KD trees, ball trees. Used for nearest neighbor search, vector similarity, KD trees. Used for multi-dimensional search. Applications. Spatial search, spatial recommendation systems, spatial AI vector search. Cloud-native scalability concepts. Tree-based systems improve. RC horizontal scaling, distributed partitioning, routing efficiency, indexing speed. Horizontal scaling, example load balancer, Node 1, Node 2, Node 3. Trees help organize. Distributed nodes, partition routing, tree-based partitioning. Databases partition large datasets. Example, root, partition A, partition B, partition C. Benefits, scalable, distributed storage. Service discovery trees. Cloud-native service discovery often uses hierarchical organization. Example, production, payments, orders, users. Real-world example, cloud-native e-commerce platform architecture. Users down, API gateway, tri-routing, microservices, PostgreSQL, B-tree indexes, Redis cache, Kafka streams, database scalability. PostgreSQL indexes. Check B-tree indexes, check partition trees. Benefits and scalable search and optimized joins. Kubernetes scalability. Kubernetes cluster, namespaces, deployments, pods. Tree hierarchy enables. Check. Scalable orchestration. Check. Resource isolation. Performance benefits of trees. Benefit explanation. Faster search O-log-n operations. Efficient routing. Hierarchical traversal. Better scalability. Distributed organization. Reduced I/O. Indexed access. Optimized lookup. Structured search paths. Common scalability challenges. 1. Unbalanced trees. Can degrade performance. 2. Massive tree depth. Deep traversal becomes slower. 3. Distributed synchronization. Large distributed trees become complex. 4. Hotspot partitions.
Some branches receive excessive traffic.
5. Index fragmentation. Database indexes degrade over time. Common beginner mistakes. 1. Ignoring indexes leads to slow database queries. 2. Overusing complex trees. Simple structures may sometimes work better. 3. Poor partition design can create bottlenecks. 4. Ignoring rebalancing. Unbalanced trees reduce efficiency. 5. No monitoring. Performance degradation goes unnoticed. Best practices. Use B-tree indexes for SQL databases. Monitor index fragmentation. Rebalance trees when needed. Partition large datasets properly. Use trie structures for routing. Use Merkle trees for distributed consistency. Optimize hierarchical traversal. Avoid unnecessary tree depth. Monitor lookup performance. Caching with tree structures. Common interview questions. 1. Why are B-trees used in databases? Because they optimize disk-based indexing and provide efficient search performance. 2. What is a trie tree? A trie is a prefix-based tree structure optimized for string matching and routing. 3. What are Merkle trees used for? Merkle trees efficiently verify distributed data consistency. 4. Why are balanced trees important? Balanced trees maintain efficient O log n search performance. 5. How do trees help cloud-native scalability? Trees improve routing, indexing, partitioning, and hierarchical resource management. Cloud-native tree-based architecture. Users, global load balancer, API gateway, trie-based routing, user service, order service, payment service, PostgreSQL, Redis cache, Kafka B-tree indexes. Feature: trees, graphs. Hierarchical: yes, not required. Cycles: no, allowed. Routing: efficient, flexible. Complexity: lower, higher. Final summary: tree structures are fundamental to scalable cloud-native systems. Important tree-based technologies include B-trees, Trie Trees, Merkle trees, KD trees, balanced trees. Trees are heavily used in check databases, Kubernetes, distributed systems, DNS, API gateways, AI search systems, load balancing. Key idea: tree structures enable scalable indexing, routing, partitioning, and distributed coordination in modern cloud-native applications.